So there's a projectile motion equation. It comes in different forms. This is one form. That's initial velocity. What do they usually do? V sub I times t plus v sub z. I think this might be h sub 0. Here, I'll explain each part though. So A is the acceleration due to gravity, right? So those are two known numbers. It's 9.8 meters per second, or it is 32 feet per second. And so since this problem's talking about feet, we're going to use 32 for A. That's it. We're just going to be plugging in 32 for A. Okay. V sub I used V for the initial velocity. So this is how much, how hard this machine is throwing the baseball right as it leaves the machine. So your initial velocity would be like if you're throwing a baseball with your hand, how fast is the ball leaving? How fast is the ball moving right as it leaves your hand? The initial velocity. And h sub 0 is the initial height, so 4.5 for this question. Okay, so if you put all those things together, it's 32 feet per second for gravity. That's constant in all situations, unless you're on the moon or something. The initial velocity for this problem is 64 feet per second. I don't know how fast that is. So that goes next to t. And then it has an initial height of 4.5 feet. So there we go. There's our function that models the height. And we could actually just call this h of t if you want to. Whatever letter you want. It doesn't have to be f. H would make more sense, I guess. B is the mathematics part where we're actually doing some of the stuff we learned in this section. What is the maximum height the baseball will reach? Well, that's quadratic, right? Oh, sorry, and this is supposed to be negative. That's a big detail I forgot, right? Because acceleration is, let me see. The acceleration should be negative because acceleration is talking about how fast your speed is changing, how fast velocity is changing. So the acceleration is negative because if you're throwing that ball up in the air, it's started at 64 feet per second, but it's slowing down because gravity is pulling it back. So acceleration needs to be negative. That's a big detail I forgot, because otherwise the quadratic would look like this. But since A, the leading coefficient, is negative in this quadratic, it'll look like this. So the height of the ball will reach a peak. And that maximum is the vertex of our quadratic, right? So we need this formula to help us find the vertex, to help us find the maximum. Okay, where B is 64 and A is negative 32 divided by 2, so that's negative 16 for A. Okay, so this is negative 64 divided by negative 32, so at 2. I said x equals all this stuff. You could just, it's just t in this equation instead of x. So t equals 2. That is how many seconds, right? Because t is time. It'll take 2 seconds to reach the maximum height. Now, what is the maximum height? That's what this part of the formula tells you, and that's why I was saying maybe we should call it h of t. If you plug in 2 seconds into the function, negative 32 divided by 2 is negative 16, then that will tell you the height that you reach at your maximum. Okay, so if we plug that in, we've got 4 times negative 16, so that's negative 64. Negative 64 plus 2, that's going to be 164. And then 64, oops, plus 4.5, oops, that's 68.5. So the maximum height for my problem is 68.5 feet.